Hello everyone, my name is Sergey. I'm a physics and maths tutor, and today I want to show a simple method how to solve a quite difficult physics problem using principle of relativity in motion. So let's read the problem. A spy submarine and the attack submarine are approaching along perpendicular directions. The spy submarine moves at 45 kilometers per hour. The attack submarine moves at 28 kilometers per hour. The spy submarine was directly ahead of the attack submarine at 12 noon. At this time, distance between submarines was 106 kilometers. The spy submarine detection distance with current weather conditions is 90 kilometers. Will the attack submarine detect the spy submarine during their motion? If yes, when will it happen? So let's start with a diagram for better understanding what's going on here. We have two submarines. This is the spy submarine. It travels from west to east. This is the attack submarine. The area of detection of the spy submarine is labeled with this red dot circle. The question is, will the trajectory of the attack submarine cross this area? If yes, at what particular moment will it happen? The standard solution algorithm of this problem includes the following steps. We should define the x-y coordinate system. Then we should define time dependencies of x and y coordinates of both submarines in this coordinate system. So the time dependence of distance between submarines can be expressed as follows. And now we should find minimum value of the obtained function using its first derivative by time. But this method involves quite difficult calculations. There is another simple method. As I said before, the spy submarine travels at 45 km per hour from west to east with respect to the Earth. But what if we choose the attack submarine as a reference frame? To find the velocity of spy submarine with respect to attack submarine, we should subtract the vector of attack submarine velocity from the vector of spy submarine velocity. So, as you can see, the spy submarine is moving in this direction with respect to attack submarine. So the shortest distance between submarines is the length of the perpendicular from this point, where the attack submarine is located, to this line, which represents the trajectory of the spy submarine with respect to attack submarine. So let's find the length of this perpendicular. Geometry will help us to do that. Right triangles OMN and AOH are similar because the angle O is shared by both triangles. Then the hypotenuse of the small triangle ON divided by hypotenuse of the large triangle OA equals MN, the side opposite to angle O in small triangle, divided by AH, the side opposite to the angle O in large triangle. OA is equal to S. MN is equal to magnitude of spy velocity vector V1. AH is the unknown shortest distance between submarines. Let's find the length of ON using Pythagorean theorem. This is a hypotenuse, so its length equals square root of this length squared plus this length squared. So the unknown shortest distance can be expressed as follows. We just plug in the numbers and get required result. As you can see, the shortest distance between submarines during their motion is exactly equal to the spy submarine detection distance with current weather conditions. So the attack submarine will detect the spy submarine during their motion, but when will it happen? It will happen when the spy submarine arrives at point H. The velocity of the spy submarine with respect to the attack submarine equals 53 km per hour. The length of OH can be calculated using Pythagorean theorem applied to the right triangle AOH. It equals 56 kilometers. So the time of traveling is equal to 1.057 hours, that is approximately equals to 1 hour, 3 minutes and 24 seconds. That means that the attack submarine will detect the spy submarine at 1:03:24 p.m. This is the answer. Thank you for watching and goodbye.